Hey everyone, welcome to mini lecture number 6 for Computer Science 163 at the University of Wisconsin-Eau Claire. We'll be talking about multidimensional arrays, which is covered in chapter 6, section 6 of our textbook. Before we begin, make sure that you understand the answers to these questions. Make sure that you feel comfortable with them and pause. As reviewed from last time, a one-dimensional array can be declared as shown here in the first line. So int is the type of variables that are going to form, or that the array is going to contain, myArray, the name of the array, and then you put in brackets the size of the array. And then if you want an option, you can stop there. You can say that's the line, I'm going to declare the variable, but I'm going to fill in the values later. Or you can say that equals and then give it some initial value. If you do that, you can take away the size of the array, the red 6 in this example, because then if you have all the values in that list after the equal sign, then the compiler knows how big the array is going to be. So then you can just have empty brackets. In memory, down below, you can see that all the values of this array are going to be stored right next to each other, and you can see how to reference them above, myArray 0 through myArray 5. That's a one-dimensional array. Now for 2D arrays, which we often refer to as matrices, it'll be similar, but a little bit different. For a matrix, we always think about a matrix having a certain number of rows and columns. So for a 2D array, if we treat it like a matrix, we can declare a 2D array as shown here, with int being the type of variable that will be stored in this array for each element, and then rows tells us which has to be a compile time constant, is the number of rows, and calls is the number of columns. So if we want to get to actually set values of this matrix or get those values from that matrix, we can do it kind of like what we did before. So if we want to get the top left element of a matrix, that would be row 0, column 0, which would be the first row and the first column. But again, C++, and just like C, just like Java, starts with indexing 0. So 0 is the first row or column, index 1 is the second row or column, and so on. So this would be the second row, the first column. This would be which row and which column? Pause it. Hopefully you got it. It's the fourth row and the third column. Matrices, you could have a matrix, for instance, that looks like this. These are the rows here, row 0 all the way to row 3. And again, there's 4 rows, so it'll be 0 to 3. We have 3 columns, so the column indices will go from 0 to 2. So think about how would you declare a matrix, an int matrix of this size. Pause it, write it down, let's try it. 3, 2, 1. Here's how you would do it. You've got 4 rows, 3 columns, so this is how you would declare that kind of matrix if you're storing integers. You could also store unsigned integers or doubles or floats if you want. So here's how you would set the first row. So you've got 10, 20, 30. They're all in row 0. So the matrix element for the first index of this 2D array will be 0 because they're all in row 0. The second index is the column, and that's the one that's changing here. So that would be column 0, column 1, column 2. Try doing the same thing for the other 3 rows. Here is the second row. Here is the third row. And finally, here is the fourth row. The first line of code, again, int matrix 4, 3, declares that there's going to be a new matrix of integers that has 4 rows and 3 columns. The next 12 lines of code, not including the comments, initialize the elements of this matrix to have the values that you see in green. Now, in one-dimensional arrays, we had a shortcut to be able to declare and initialize an array all in one line. And that was using the curly bracket notation. We're going to do almost the same thing here, but we're going to have to do it a little bit differently. The very bottom line here shows how this two-dimensional array or matrix could be initialized in a single line. you'll notice that the first part on the left-hand side of the equals is the same, so we're declaring the matrix the same way, but now we are initializing it a slightly different way than what we did with the one-dimensional arrays. And actually, it's not that much different syntactically. What's going on here is you see an outer set of curly braces, and then you see 4 sets of inner curly braces. The outer set of curly braces is to say, this is the value of an array, and this array has 4 elements. There's something, comma, something, comma, something, comma, something. That means that this array is going to have 4 elements. And then each one of those elements is itself an array with 3 elements. So the way that C++ treats multidimensional arrays is, rather than it being like a single array of values and then like a matrix of values and then like tensors of values, the way that it treats it is it's an array of arrays. Or if you had a 3D array, you could have an array of arrays. So when you initialize it, you're initializing the first dimension first, which is the outer curly braces represent that first dimension. So it's going to be an array of dimension 4. And that's what you see in the declaring too. And then each of those inner dimensions is going to have dimension 3. And again, you got to make sure that each of the inner dimensions has the same number of elements. So you can't have one row with 5 columns and another row with 2 columns. You'll remember that when we declare a one-dimensional array, the computer will reserve a block of memory big enough to hold all the elements of that array next to each other in memory. When we declare multidimensional arrays, the computer does the same thing. It reserves a block of memory big enough to hold all of the array's values next to each other in memory. On the previous slide, we declared a matrix of integers with 4 rows and 3 columns. The computer will then reserve a block of memory 48 bytes long, enough for 12 integers, where each integer is 4 bytes. The row of blue boxes in this image represents how the computer stores that matrix in its memory. If you look closely, you'll see that the elements of each row are stored together and are labeled matrix 0, matrix 1, matrix 2, and matrix 3. That's because of how C++ treats multidimensional arrays. A 2D array is actually an array of arrays. The matrix variable is a 1D array of length 4, where each element of that is itself a one-dimensional array of integers of length 3. You can actually pass matrix 0, matrix 1, matrix 2, and matrix 3 to a function that calls for just a one-dimensional array of integers. That function would then operate just on that row, separately from the rest of the matrix. Pretty cool. Let's take this in a slightly different direction. Now, you can initialize the elements of an array right when you declare it, or you can initialize them one by one, as we saw before. But a lot of times when we initialize the elements of an array, we do it in a loop, at least especially in scientific applications, or mathematical applications too. So we'll do a loop over, say 40 times, and over an array of size 40. And so each iteration of that loop will set a different element in that array. So let's see how we would do that for a multidimensional array. Let's say that we have 40 rows and 30 columns. We declare a matrix of doubles of size rows and columns, so 40 by 30. And notice that rows and columns are declared with the const keyword in front of it. That means that those values aren't going to change, they're constant, and so therefore the compiler knows that it can use them as the size of the array. Otherwise we'd actually have to stick 40 and 30 into the size of the array. If you don't have const, the compiler will complain because you can't. Basically, the size of the array has to be a constant. So let's say that we want to set all of the elements of the array kind of like this, where you have the first index being like, to the left of a decimal, and then like the 22 here would be to the right of the decimal. We can do that by setting. If we're trying to set the R index for the rows and the C index for the columns, we can say the row plus C divided by 100, or 0.01 times C. So if we do that with R equals 15 and C equals 22, we get 15.22. Okay, why? Just because. It'll be easy for us to see what's what. So how do we do that? First, we need to iterate over either the rows indices or the column indices. Let's do the rows first. because they're kind of first in order anyway. So if we do this, we can have a variable called r, set that to 0, loop from 0 to rows, so it'll actually go from 0 to rows minus 1. And then we'll have an intermediate loop here. So this is a loop within a loop. So from here, we're counting from c equals 0 to c equals columns minus 1. And then this will iterate, and this will indeed have all of the elements of the array be kind of like that 15.22. So if you have r equals 13 and you have c equals 10, it'll be 13.10. Okay, cool. So this is how you could do it. Now there's another way. I just said, why don't we do the rows first and loop over the columns within the rows loop? So this is a loop within a loop. What if we switched those loops? So what if we did the columns first and then the rows second? So this is going to say, column 0, and it's going to loop over all the rows in that column. And then it's going to go to the next column and then loop over all the rows in that column, and then loop over the next, or go to the next column, loop over the rows in that column. Does it matter how they do that? All that we've done is switch those two lines of code. These will actually do the exact same thing. So it really doesn't matter. However, the first approach is actually faster because it's going to be accessing all of the elements in the matrix in the order that they are done in memory. And the other way, it's actually going to be jumping. Oh, my cat looks so cute. Oh, hey, kitty. Sorry. So the second way, it's going to be jumping around in memory, which is slower for the computer to load all the variables in memory because it has to go around and look for them. But if it's looking for places in memory that are all in a row, then the computer can load those in memory really, really fast. Let's go in a different direction with function calls. How do you pass a multidimensional array into a function? Now there's two different methods for this. And the first one is when you pass an array into a function, then that function has to include the size of all of the array dimensions. So let's skip down to the main method here first. I declare an int array of size 3 by 4. I pass that to my function initialized to 0. I'm going to set all the values of this array to 0. So now in that initialized to 0 function, the parameter is declared as int array 3, 4. Notice that the brackets are after the variable name, and then I also am including the size of each of the dimensions in this array. So 3 rows, 4 columns. And then I loop over the elements and set them to 0, and I return. Cool. So that's one way that I can do it, but it's not quite as flexible. What if I wanted to pass a different size array, for instance? So I can do it one other way. I can pass the number of columns, but not the number of rows. And for higher order arrays as well, you have to specify all of the other size dimensions except for the first. So the first one can have empty brackets, but all of the other ones you have to specify the number of the size of each of those dimensions. And this is fine, it's valid, but it's a little bit tricky because now inside of the initialize to 0 function, if we want to initialize that to 0, we don't know how many rows there are. So that means we can't use our for loop that goes over all of the elements in that row because we don't know how many rows there are. We don't know how many times to go through the loop. So that's a little bit trickier. And you can use that if you want, but it's a lot more difficult, and I wouldn't encourage you doing that. There's also another way if you use pointers and dynamically allocated arrays, but we're not going to be discussing that till later, so let's not. Let's now go to talking about higher dimensional arrays. A one-dimensional array, we talk about, we've covered that. A two-dimensional array we've called a matrix. Three-dimensional array doesn't really have a good name other than just a rank 3 tensor. And a fourth-dimensional array would be a 4-rank tensor, and so on and so on, if that's your thing. But let's look at the example of a three-dimensional array. Here we have, we're declaring an array of doubles called values. So the variable, the array name will be values. It's going to have 40 rows, 30 columns, and 30 of whatever is next. I don't know what you call it after rows and columns. And you can iterate over them just like you did with the two-dimensional array. You just add another for loop to iterate over all of that new dimension that you've added. And you can do that for the fourth dimension. Just add brackets when you're declaring the size of the array, and then add a for loop within a for loop within a for loop. uh, uh, to iterate over all of the different values. Now, how many times or how many dimensions can C++ have? It's actually not specified. The C++ standard suggests that that compilers allow for 256 dimensions. But if you try to make an array of, say, 100 dimensions, just two elements in each dimension, but you have just, say, 100 dimensions, it's going to blow up and your computer's not going to be able to fit an array of that size. So the actual size, the maximum size of the array is constrained a little bit by the size of your computer's memory, and a few other things too. I've never really seen anybody have more than a fourth or fifth dimension array. So in summary, that's multidimensional arrays. They're really cool. They're really useful. But just to make sure that you've picked up on stuff, here are some questions. I encourage you to pause here and really consider each of these questions, write them down in your notes, and yeah, let me know if you have any questions. Here's a practice problem for you as well. I encourage you to try checking it out. If you have any questions about this, let me know, and good luck. I hope that these practice problems have been useful to you. And let me know if they are, or let me know how they could be better. Anyway, that's it. Take care. Have a good rest of your day. Jess out.